Hey everyone, it's Mrs. Conway, and it is time to learn how to do word problems with growth and decay, which I know everyone tends to freak out about word problems, but I assure you these ones aren't so bad. And they're super practical. So we're going to talk about bank accounts, and we're going to talk about the value of cars. So first of all, formulas. And words to think about. So for growth, words that you might see are increases, grows, or annual interest, which I know sounds weird, but everyone always gets confused about that one, so I like to put it on there. If it says annual interest, you're getting that money. Okay, and our formula is y equals a times 1 plus r to the t, and this should look pretty familiar. It's just instead of b right here, we have 1 plus r. Now decay, you're going to see words like decreases, decays, or depreciates. They should be pretty easy to remember. They all start with D. Okay, and then the formula for that is very similar. The only difference is it's 1 minus r to the t, which should make sense because we're talking about decay, so it's going down by the rate. All right, so then what's a, r, and t? So in the problem, what you're going to see is a is your starting amount, your initial amount. So however much money you start with, or people you start with, or whatever it is the thing is talking about. R is going to be your rate, which is the percent divided by 100. And then you just need to make sure that because it's going to say percent per year or percent per month. Make sure that matches with your time, which is T. And I'm pretty sure in the problems you'll get they'll always match. And then that's really it. You're just going to plug the numbers into these formulas and find your answers. So let's do an example. Growth. Remember our formula up here, y equals a times 1 plus r to the t value. So your first job when you get a problem is to decide, is it growth or is it decay? This one is pretty obvious. It says grows. So it's a growth problem. A town has a population of 13,000 and grows 4.5% every year. What will the population be after 13 years to the nearest whole number? So first let's highlight our important information. 13,000 people growing at 4.5% over 13 years. So what's A, R, and T in this? So A is going to be your 13,000, our initial population. R is our 4.5% divided by 100 to give us 0.045. If you're good at going from percents to decimals, just R is the percent as a decimal. And then T is 13, and it is percent every year and in 13 years, so we're good. So now all we do is we plug the numbers into the formula. It's going to stay y equals, and then instead of A, we're going to write 13,000 parentheses 1 plus 0.045 parentheses to the power of 13. So now what you want to do is you want to pull up a calculator. Now here's the calculator that's on the laptops. If you want to use that calculator, just turn it to scientific mode. It'll make it a little easier. Now you're just going to put, starting after the equal sign, you're going to type it straight in the calculator. So 13,000. You do need to remember, because these are of the way this calculator works, right here you need to put times before you put the parentheses. It doesn't know that if you put it next to the parentheses you mean times, so you need to make sure you put that in there. 1 plus 0.045, close the parentheses. This little button right here with the x and the y is going to be your to the power of 13. And then just click equals. All right, so I got 23,038.549. So when I write that down, I just wrote the 5, but then up here, if you notice, it says round to the nearest whole number, which should make sense because we're talking about population, which is people. So if it's 0.5, we round up to 23,039 people. And that's all it is for the growth kind. So next let's do a decay example. So how do I know this one's decay? it depreciates at 12.5% per year. So I'm going to use my decay formula. The only difference is I'm going to minus that R instead of adding it. Okay, so we have initial value of 20,000 at 12.5% per year for 11 years. So A is 20,000, R is 12.5 divided by 100, which is 0.0125, and T is going to be 11 years. So now we put it into the formula. 20,000 goes where A goes, parentheses 1 minus 0.125, close parentheses to the 11 power. Type that straight into your calculator, and you should get $4,603 and then I got like 82258, and it just keeps going. Again, we have to round, this time to the nearest cent. They mean dollars. Guys, when you talk about money, you have 2 decimals, right? So we're just going to stop after the first 2. So it's going, and then since this number right after it is a 2, which is smaller than 5, it's 4,603.82. Honestly, the biggest problem people usually have on this problem set is rounding errors. Remember, 5 and higher, you round up. 4 and lower, round down. And you're looking at the number after the last number you want to write. Okay, so when we say round down, it really means keep it the same. So in this case, we're rounding down by not going up to 3. We're leaving this at 2. And that's it. So your problem set has a couple of these and a couple review, and you should be able to get them done now. So good luck.